Sorry, being recorded for posterity. All right, in lieu of questions, we'll pick up where we left off. And where did we leave off? We didn't do the ball problem, I'm pretty sure. We did the plus minus 0 for the big 4. You got all 4 of them? Okay. So we'll start out with the ball in the air problem. If any of you watched the video already? Okay. You don't have to worry about that part. All right, so throw a ball in the air, it goes straight up and straight down. Now I've drawn a little bit of a spread here just to, otherwise, if I drew it like that, it's a little bit misleading. It is going up, coming straight down. I'm not worried about any sideways motion. No air resistance. And I'm going to identify 4 key spots. A, or 4 key times. A, time just after the ball leaves hand. So that's time A. Time B, B is the time ball is at peak. Ball C, time ball is at same place as at time A. I guess I should just write A. At A, except on the way down. And then D is the time just before ball touches ground. So I would note this on the diagram by just putting an A here, B, C, and D. These are just moments in time. Questions to hear? The problem starts just after ball leaves hand. Problem ends just before ball touches ground. So the person is there just as an excuse for why the ball is in the air to begin with, but the person really is irrelevant to the problem. I could have just as easily done, the ball comes into existence heading upwards at time A. As said in one of the videos, motion has no memory. The fact that how objects get to where they are is irrelevant. What really matters is what it's going to do next. All right, so what the task is, given position, displacement, and again, since I didn't put any qualifiers, this is overall displacement, velocity, and again, without any qualifiers, it's instantaneous velocity, and acceleration. What I want you to do is identify where is it positive, where is it 0, where is it negative. Now, in order to be able to do this, we do need to define a coordinate system here. And just so that we're all on the same page, we are going to make up positive, and the ground is my origin. Ground is 0. Questions to hear? All right. Give people a little bit extra time to finish writing stuff down, and then I will talk about how do you actually communicate the answer. And there is a PowerPoint under Course Documents, Chapter 3, called Directions of Motion, where I go through a lot of the same stuff. So this is going to be off camera, but the notation is if something is happening from A to B, including at time A and at time B, a notation, I'm pulling this from the math people, AB with brackets or square brackets, this would mean from time A to time B, including both, including A and B. If it's from A to C, I don't have to include B in that, because so if it's from A to C, A comma C, so this is from A to C, including both. If it's going from A to C, it includes time A, but doesn't include time C, square bracket on A parenthesis on C. So this is from A to C, including A, not, I guess it just could write excluding C. So square bracket means I'm including that moment in time. The parenthesis means it stops just before or just starts just after, depending on if the parenthesis is on the left side or the right side. So it's not including the time point if there's a parenthesis there. If something happens at point A and point B, but not in between, you just write A comma B, and so this is at A and B, but not between. There are other ways of communicating this exact same thing, and then that PowerPoint that I mentioned earlier, directions of motion, I think I give 4 different ways of expressing the answer at the end. And in the older tests, I basically do this. In the newer tests, and I don't know if they're posted or not, I actually there's a whole page of 4 different ways that you can express it. You just pick the one that you like and express it that way. Don't pick 2 of them, as some students have done. Or if you pick 2 of them, don't give contradictory information. All right, so what I would like you to do, I guess one last chance for questions before I give you time to work on this. Right, what I would like you to do is to try to fill out the table as best you can. Feel free to work with a neighbor safely, and give you about 10-15 minutes to try to see how much of this you can get on your own before we talk about it as a group. And And I'm going to erase this, what I have over here, and just write it in smaller space because I want to use the space right below it. Remember that position is positive when it's on the positive side of 0. Displacement's positive when it's on the positive side of the starting point. Velocity is positive when going in the positive direction. And acceleration is positive when the net force is in the positive direction, or it's speeding up while going in the positive direction, or slowing down going in the negative direction.
square bracket up there?
Yeah.
So at D it's still going up. All right, I'm good with that. Oh, you're about to ask a question then? Yeah. You don't need to, I'm going to write the answer 3 different ways. But, you know, pick the one that you like the best. Confusing position and displacement here. Position appears above where 0 is, or the origin. Displacement appears above 0. So I'm good with your displacement line. So you're saying it stops at that point? That point? This is instantaneous velocity and overall displacement. This velocity is not going to be the same as the displacement. If I ask for average velocity, then yes, I'm good with that. But this is instantaneous velocity. Remember, velocity equals 0 when it stops.
So I'm gonna present the answer three different ways. So, yeah, if the others are clearer to you, then go for those. So you're saying it's not moving at this point? At that time? Yes, which is the way you have marked here. Does it ever stop? No, because D, it hasn't touched the ground yet. It's still falling at D. You solved the problem before it is. It's, if you write it that way, what you're saying is only those two times is it negative. You want to include the stuff in between if you need to use some parentheses or brackets or somehow indicate that it's in between. Pardon? Yes. All right, so because you're saying it stopped here, the square bracket also said, right?
So that would be parentheses.
That would be a parenthesis there, and also. Despite what some students have insisted on in the past, an object cannot have positive and negative velocity simultaneously at the same moment in time. Or some will try to convince me, it cannot have positive, 0, and negative all at the same time also. Not in classical physics. The object is stopped at that point. Let's take a look as a group. So position. Where's 0 to begin with? Okay, which is? This is where position is 0. When is it the ball on the positive side of 0? Yes, the whole time. It's never negative. So position from A to D, and then neither of those. Now I could have expressed it a different way. In this chart right here, it's positive the entire time. Or expressing it over here, I just shade in where it's positive, where it's greater than 0. Now recognize my columns in these last two, in the red and in the green, I'm covering everything. I have the key times that I have mentioned, and I have the times in between. So it's at A, between A and B, B, between B and C, C, between C and D, D. Displacement, where is displacement 0? Yep. Because displacement cares about where it's an object relative to where it started. Well, time A is just after ball leaves hand, and hey, that's where the problem starts. So displacement is A there. When is the displacement on the positive side of the starting point? Okay? That is true. It can't be at A because A I've already got there, so A to B. Am I including B?
Yes.
Anywhere else? All right. Classic number line right there. I assume most people are familiar with the number line. Yeah, that's somewhere in elementary school. All right. So when I am doing position, I just orient it so the positive side's going in the right direction, and I put my 0 right where 0 is. So anything above that, I've got positive position. Displacement, I now put 0 at my starting point. Anything above that is positive. Below that is negative. So, now you counted from A to B. Anything else? Yep. Am I including C? Shay says no. Is Shay right? I gotta go back. Some people have your back. So, then where's C? Yeah, because A and C, they're at the exact same point at time A and time C. And negative?
C to D.
Including neither of them?
Only including D.
Okay. So not including C, including D. Now I can express that down here. I know my displacement is 0 at A and C. It is positive in between them and negative afterwards. Or on my chart over here, it's 0 here at A and C. Positive. And negative. Velocity. Any questions up to here? All right, velocity. When is velocity positive?
A to B, not including D.
All right. What happens at B?
It stays the same.
Say it one more time.
And it's 0.
Okay, yep, I heard that one. That's not what you said to whoever.
It said stays the same.
Okay, stays the same as, oh,
It's B.
okay. And then, what happens after B?
B to D is negative, not including D.
Right, it's falling. So not including B, because I already have that covered there. To D, including D, because it's still falling at D. So it's 0 at B. It's positive before that. It's negative after that. Or, on the shade-in version, it is 0 at B. It is positive before that. It is negative after that. And now acceleration. So as it's going up from A to B, speeding up or slowing down? It's not supposed to be a trick question here. When the ball is going from A to B, is it speeding up or slowing down?
Speeding up. Speeding up.
Speeds up as you throw it up in the air? From A to B, it's getting faster?
It slows down.
I hope it slows down, otherwise, why would it stop? So from A to B, as the ball is going up, It better be slowing down because you claim that it stops here. I claim it stops here. So if it's slowing down, what do you know about the sign of acceleration?
Negative? Wait,
Why would it be negative? Not because it's slowing down automatically.
if it's slowing down, velocity and acceleration are opposite signs?
So from A to B, it is slowing down, therefore it's an opposite sign. It's got to be opposite of what I had up there. What about as it's falling? Speeding up or slowing down? What does that tell you about the sign? Why?
Because the velocity is negative.
And so the acceleration is the opposite sign? That means it's slowing down. If it's speeding up, what's true about the sign of acceleration and velocity?
They have the same sign.
Yes, same sign. So it's negative. Obviously, I've left B off. This speeding up, slowing down doesn't really work at turnaround points. But what's happening at B?
It's 0.
So acceleration 0 there? Is that what I just heard? With a question mark? All right, if acceleration is 0, what do we call that? What's the word for when acceleration is 0?
Origin, is that it?
That's when position is 0.
Equilibrium?
That's the one I'm looking for. Acceleration is 0, we are in equilibrium. If acceleration is 0, what are the other two things that are also true?
Velocity is 0.
The what?
Velocity is 0?
No.
The change in velocity.
Oh.
Yes.